There is a lot of definition flowing around, about IoT. It's one of the most hyped up technologies. So I'm going to talk about 4 different stakeholders who have something to gain by coming up with their own definitions of IoT. So you talk of IEEE, which is effectively a standards body. So they talk about IoT as pieces of nodes or pieces of data, like the sensor over here, which is sending packets of data every time or every second, and getting it to a back-end system which can analyze that data and make some sense out of it. That's about IEEE. We can also look at Cisco, which is a big networking company. They talk about, there's a whole thing about Internet of Everything. So the IoT gets used and abused in different ways. It's Internet of Everything, Internet of Things. So they want to sell more networking gear. So of course it's all about physical objects being connected. Then you've got Forbes, who comes from the whole kind of a mass media perspective to talk about IoT, but it's all about how it is going to change all of our lives. That's the perspective that Forbes takes in. And of course, Morgan Stanley has the financial perspective, which is how can we change industry, which I think is where most of the value is going to be. How can we transform industry, which is still sitting at kind of a 90s technology, and bring in the modern computing revolution that has happened in the consumer world into the industrial world. So that's the kind of a Morgan Stanley perspective we tend to see a lot. This is a interesting peak and trough chart. This is from a company called Gartner. Gartner is kind of the leading IT analyst firm across in the world today. So they tend to track different technologies as they go through the curve. So as you can see, IoT currently is right at the peak. So it's kind of a peak of inflated expectations right now. And the biggest challenge it is going to go through this trough, so which is called valley of death. So the question here is, how fast can it get out of the valley of death and move to the slope, which is where you start getting some value out of the investment that people are making. So you can, I'm sure you guys might see some of the technologies that you are used to. I mean, for example, I worked in machine-to-machine communications 10 years back, and it didn't deliver. It is still stuck in that trough. The amount of investment 10 years back we made into whole of R&D, the returns that it got was not substantial at all. Now, one technology I will say which has come out of this is a very geeky thing called in-memory analytics, which is all of this big data that you are getting, how fast can you process that in a kind of a sub-second response? And that is something in-memory analytics will give you in a database. So that has actually come out, and it has actually delivered value. So you can see 10 years of R&D has given some returns on the back of that. So we will wait and see. Hopefully next year we'll see where it is on the slope, So there are 2 flavors of IoT. There is the industrial IoT, and of course there's a consumer IoT. So I'm going to talk a bit around consumer IoT, which is where the whole notion is sensors, how it connects to the world around us, be it our TVs, be it our microwave, be it our kettle, fridge, everything. How can it improve our lives? So one of the notions we have is this phone. This is the smartphone, which is going to actually transform everything. So you can see you can be in the shower, and effectively the smartphone will be able to control lighting, kettles, everything you talk about. Now that is a fundamentally different environment. It's more forgiving environment, should I say, consumers, to the industrial environment. And the primary reason being, industrial environment cannot rely on wireless network going down or some kind of sensors malfunctioning. As you can see today, we are more adaptable to picking up the low temperature, but industrial environment won't be. So I think the challenge of IoT is very much to prove its value in the industrial environment, and that is where the maximum returns we should get out of it. And we will talk about some of the flavors of industrial IoT that we see as we move forward. Right. I think we heard yesterday from the gentleman from GM about the need for network factories, need for getting real-time information out to the guys who are going to make the decision. So what we see in the market today is industrial IoT is slightly different because you've got a whole bunch of sensors which are already in place that has been deployed in the last 15, 20 years. So we have a client which is a gas processing plant, and they have like 20,000 sensors. So when we or anyone else goes in and say, hey, we got a new sensor, I think the immediate reaction is we already have the data. We have already been storing this data for the last 20 years. help us with that. So we see that sensors are already in there. So building a new sensor, yes, is going to be good, but it's not going to move the needle far off for these guys to adopt these technologies. The other thing we also see is network connectivity. Ethernet is quite pervasive out there, but one of the challenges they face is wireless, because deploying an Ethernet network takes a lot of time, a lot of disruption it can happen to process. So wireless, having a stable wireless connectivity is quite key out there. The other thing which is quite interesting, I personally found after coming from the machine-to-machine world was there is a lot of systems already in place. So you find there are factory automation systems, there's different types of acronyms you can think of, And when I sit in meetings with these clients, and they all talk about, I've got 10 energy management, 5 SCADA systems, different control systems. And the challenge they all have is this is meant for different users, and there's no layer to bring all of that together. And our view is IoT can actually bridge that gap, bring the data from these disparate sources, and provide an analytics layer on top of that. Then it can create some value, because then it will help in changing a process for say. So that's the area where we see there is a lot of potential in there. Yeah, as I said, some of the challenges. So data. So data being in silos. We're talking of kind of a multitude of systems that are sitting there. And one of the things that we constantly see is a lot of these systems actually provide the data which is the minimum requirement that the factory had at that point when they set it up in the 1980s. So it is like doing very basic control systems. Now, when you talk of efficiency or operational efficiency, energy efficiency, whatever it is, there is no correlation. So there is a bunch of data that does control signals. It does not correlate to how the efficiency of that equipment is. It does not show how the entire process is working, and things like that. So what we see is data in silos is a big issue for these factories. I'm sure people here might agree or disagree with me on this, but we have seen that as a big issue. Security, of course, everyone is paranoid about Stuxnet and all kind of stories that's going around. So IoT has a security, I won't say an issue, but security is a major thing on the table. So any conversations we have, security comes up as, I would say, the first or second item on the table. So security leads to all kind of things. It leads to, will my sensor get hacked remotely? That might stop my pump, my process, everything. Or will it be that you connect your data to the cloud, which is cloud computing, and someone hacks the data from there, and then they can understand how my factory production is going, what is my margins. So all sorts of things can boil on from there. So security, we find, is kind of a second or first issue that is on the table. The other big thing we see is, which I was very surprised coming from the computing world, is people look at SCADA systems, and it is actually sitting in a computer in one machine and in the corner of the table. And that's the bit that people look to. There is no accessibility of that system from your laptops, from your tablets, or whatever it is. And that is what we see as another big challenge industrial automation companies have and industrial environments have. So any IoT system needs to be able to adapt to multiple users, multiple type of information they want, kind of different types of KPIs they're looking for, and stuff like that. So the variability of what you see in an Amazon world or an eBay world is the kind of stuff we need to bring into the enterprise world in order to deliver any value to them. So these are some of the key challenges that we see as IoT as we try to deploy this thing, moving out of pilots into production deployments. We come across these things kind of a day in, day out. Some of our clients are looking at ROI, return of investment or break-even is within a year. And in order to achieve that kind of break-even periods, we need to really focus on the low-hanging fruits or the big items. And then you can go for the kind of a long tail of other optimizations that you can achieve. So this 80-20 rule is something that we tend to follow quite a lot. And that kind of helps us to, when you go into a factory, to look at which are the systems we should target to deploy an IoT application and get some value out of it. And that rule we tend to follow quite religiously time and again. Right, so I'm going to talk a bit on applications, try to make this a bit real rather than a bit fluffy and theoretical. So there are two industries that we have worked in for the last 3 years where we've got a lot of experience on. Mining. Okay, it's not very sustainable, but they're trying to be sustainable. So we have been working with one of the largest uranium mining company, and they have a bunch of wells across 100 kilometers in a massive field. They have sensors all around. One of the biggest challenges they have is they put in a liquid in high pressure down the ground, and they want to get it out as well. And they want to make sure the same thing comes out. Otherwise, there is a problem there. So they have all the flow sensors, pressure sensors, and everything else. But what they don't have is an ability to understand how do you maintain the balance of system. So this is a classic analytics where you can look at the pressure and flow that is going in. You can analyze that over time and help them to predict or forecast what is the kind of pressure, what is the kind of amount of liquid that they should put in tomorrow, for example. So this kind of injection, and this is a similar case study we're seeing in the oil and gas fields as well. So the whole thing is about how do you take sensor data, combine it with different types of other information, be it energy of the pump that is driving this, maybe looking at the efficiency of the pump that is driving the liquid down, and come up with a way that what you call complex systems modeling to model that whole process, and then tell them what is the optimum way to run this thing. So we've been working with this client for around a year now, and we've been seeing as and when we start looking at different processes, the optimization opportunities are huge. I mean, this client uses €1 million a month energy bill they have in just one plant, one site, and they have kind of 24 sites like that. So the kind of price is really high, and I think you might have come across the GE came out with the 1% efficiency gain. So for industrial IoT, even if we achieve 1% efficiency gain, that's huge. That's kind of a game changing for the world around us. And that's what we're trying to achieve. So mining is quite an interesting application. People don't tend to relate mining with IoT, but they are actually well thinking ahead. And for them, it is a kind of necessity. If they can achieve these kind of gains, they can make everything more, and commodity cycles are way down, pricing cycles, so anything that can help them to improve the factory is quite good for them. So mining is one. The other area that we have got in is classic process industry. Now this is quite an interesting area because there are different types of processes, as we heard before, pharmaceutical, semiconductor fabs, which is where we have got some experience. But what we try to do is we try to break the entire factory across 3 types of systems. We call it generation systems, distribution, and consumption. So generation is all about when you are creating a lot of air, water, gas, and you're pushing it out into the production system. So what we have started to do is try to model that entire factory based on those generation systems and find ways how we can optimize that. And there are different use cases. So one of the applications in distribution, which is quite interesting, is tracking air leakage. You know, typically air leakage tracking has been a manual activity. Somebody going in and kind of listening out to the air leaks that are happening once every week. Now, how can you automate that? Because of course, having an OpEx cost like that every week is not beneficial for people. So we have looked at how can you deploy a kind of a mobile application that can use its sensor here to listen to it and capture where the leak is and stuff like that. So there are different things you can do, which actually doesn't mean you have to put a sensor in there. And then we talk about the consumption area, which is the factory production systems, which is another area where IoT can have a big benefit in. Some of the common themes that we see, sustainability comes in as we start discussion. It doesn't come in as an immediate first starting point, but the moment energy reduction, which is a direct cost for the operations team, they start understanding that, and they understand that very well. So IoT's impact on industrials very much is around sustainability. In terms of what the technology can do, so one of the things we always say is when you go and talk to people, we don't talk about IoT, we don't do any acronyms. We only talk about what's the value, where is the value this kind of sensor, modern analytics will bring it for you. So it's all about the use case. So what is the user scenario? How can you improve a workflow, improve someone's job better? So one of the things that we found is there is a lot of system already out there, so integration. How do you bring data out of these archaic systems using some modern standards is really key. The other thing we also see is how do you instrument assets with sensors what is currently not available. So for example, if you take a big pumping system, they already know the flow, the energy, all the things that is being consumed by these massive pumps. What they don't have, for example, is an inlet and discharge pressure. So they don't understand what's the head pressure that is going out. And you need that head pressure data to understand the pump's efficiency. So that is, so what we did was we retrofitted those head pressure sensors. We deployed a wireless sensor network and we started pulling the data out. So we got that data, we took the data out of their existing SCADA system, combined that together and gave them a view. So that's the kind of application that we are seeing is going to be adding value. And of course, there is the oft-repeated term of big data, which is another IT industry acronym, which doesn't mean anything to people outside the IT industry, but it just means a lot of data. So what do you do with lots of data? How do you compress the data? How do you make some sense out of that data? How do you draw patterns from that data? Those are the things we try to grapple with. And modern computers are getting better at doing that. One final point which I'm quite passionate about is this human-computer interface. So if you look at a traditional industrial SCADA system interface, it is pretty boring. Just put it mildly, it is a green screen IBM computers. It is really boring, it just shows a bunch of graphs and stuff like that. So what we are trying to do is how can you bring in the modern Amazon or the iPad or the iOS style interface of apps into that domain. And of course that scares people a lot, but they understand actually the apps actually perform one function and it does very well. It does it better than anyone else in the world. So that whole human-computer interface we believe is going to come and is going to change the way factory operations is done. So that is something which we have started doing pilots with various large industries, and they are very interested to look at building apps for specific domains. So be it like a mining company's dispatcher or operation team, they have their own app which is on a phone. Android, cheap Android phones are all around, and it does one thing very well. So that's one of the common themes that we are seeing. So few takeaways from my end. Data, as Steve mentioned, this is 90% of all the data that we've ever created was done in the last 2 years. I mean, the amount of data that we're getting is pretty scary. Some of our clients are getting data every second. They want data every second to be stored and processed. So I asked the question, what did you do before? You had this data. And the answer was we only stored it for 3 days. And we kind of archived it or stored it somewhere else. So they had no idea beyond that 3 days what they could do with that data. So those are some of the requirements for any IoT system needs to be able to handle. As I said, the kind of fruits of any optimization can be massive. I mean, GE's prediction was 1%, and oil and gas will have that kind of efficiency gains that if it is able to deliver. A talk around Cambridge, of course, you guys might have come across ARM. So ARM is kind of at 99% of these phones have got ARM chips in it, ARM design chips in it. So we work closely with ARM, and ARM is kind of leading this whole charge of IoT. You will see a lot more action coming out of ARM. So we work with ARM very closely. We have instrumented their campus here in Fulbourn, and we try to test different things. Who knows, there might be drones coming in tomorrow in the ARM campus. But that's pretty much from our side. Thank you.